Hey everybody, and welcome to Hambilly Radio. I wanted to take some time today to take a look at long-term storage of lithium iron phosphate batteries. I have some surgery coming up, and so I know that I'm not going to be out on summits for a little bit. You may have noticed I haven't been posting as much content lately. That's due to some physical stuff I've been going through. But as part of that, I need to make sure that I don't leave my lithium iron phosphate batteries, my bioenno batteries, overcharged, because if you leave a lithium iron phosphate battery at full charge, there's a couple of things that can happen. It puts stress on the battery cells to leave them fully charged, and so the chemistry can degrade and can to some degree damage your battery. Bioenno recommends essentially fully charging the battery and then discharging it to 50% before you store it for more than 6 months. And even then, when you do that, you want to periodically check the voltage and make sure that stuff is okay. You don't want the voltage to drop too low. But lithium iron phosphate batteries, they should only drop, maybe a percentage or two of charge per month, I think, is the figure I've seen. So what we're going to do, I'm going to open up the EMP can. We're going to see how prepared I actually am, because I haven't opened it up in a while. But then we're going to discharge the batteries down to about 40 or 50% for long-term storage, just because I know I won't be taking them out for a little bit. So let's take a look at the can and we'll see what happens. Okay, so I already opened this up and took the foil off and the cardboard spacers at the top, just so I could do this one-handed. So here we have what's inside the EMP can. There is a 40-watt Flex solar panel. Those are excellent. That will run with the Jenison solar charge controller that should also be in here, because that puts out enough, and you may be able to see it here, puts out 19 volts on the DC output, and you need voltage about that high in order to charge a 12-volt battery off of that. It takes about 19 volts to actually get a solar charge controller that's built for 12-volt batteries to kick on, unless you have a boost controller, but that's a different thing. I've got my mountain topper radio in here. It's wrapped up in a washcloth, but that's got my little 9-volt batteries to run the mountain topper Morse code radio off of. So I've at least got a Morse code radio in there. I've got a little beat up Linux laptop that I can use to run different ham radio programs. I can use it to run digital modes if I've got USB cables and stuff in here to do that. In here, this is a little molly pouch, and I have, it's a little difficult to see, but I've got a Yaesu FT65 down in there. So that should be good to go. A few different accessories with that, just included in that molly bag. Here I've got probably the most important piece, which is my TX500. That's my Lab 599 TX500, again wrapped up in a washcloth just for storage. I've got a couple of things here. That's a counterpoise. And let's see, my battery ought to be down in here. So let's see here. Got some coax. Got the different pieces for the microphone and some data cables and things for the TX500 in there. Some coax. I think that's RG174. It's really thin but very compact. Got my coax connectors. I don't think my battery is in here. I've got some throw line in there. I've got a pair of headphones down in there, and I've got a little pocket audio recorder, which that could come in handy if I needed to take notes on something. All right, so here I've got a 9 amp hour bioenno battery. We're going to check that. I've got a manual tuner that will handle 100 watts. That's the MFJ 9201. Excellent little tuner. Especially, you know, if you're going to throw something in an EMP can, it's nice to have things that work without batteries. I've got a Morse code key in there. It's an iambic key. And a few cables for that Morse code key. This is important. This is my Jenison GV5 lithium. That's the solar charge controller, which this is so efficient. I've charged that 9-volt battery while running the Lab 599 nonstop just outside. I mean, I know outside in the daylight in the afternoon, it's not a big deal. That's what solar panels do, but very efficient, very compact. I've got some Anderson power poles that I just put on the end to make it very easy to set that up. And there's a few other things in here. This is a backup solar charge controller that's also MPPT. This puts out a ton of RFI. So it's not great for ham radio, but it is great for as a backup, just if I need to charge stuff. I've got a power meter that I can use to monitor stuff. I've got a cigarette lighter attachment for my Yaesu radio. I think that's actually for my FT70, which isn't in here. Charger for the little laptop. This is just a wall wart that I took from an old Bluetooth headset I had, and I can use that to plug up to something and charge something with micro USB. And another important thing, I've got a little Mobilinked TNC3 right there. So that will let me do APRS. It will let me do different data modes. Very nice little piece of gear. You can use that with just about anything to turn any handy-talkie, really, as long as you've got the right cables, into a little digital, that you can do a lot of different digital things with it. With ham radio and with that laptop especially. But let's see. So the main thing we're going to check here, there's this battery. So I'm going to open this up, and I got to figure out what I did with my 3 amp hour BioNO, because I thought it was in here. So before I do anything else, I'm going to go look for that. All right, I found my other BioNO battery. This is the 3 amp hour, and it was in a bag right next to the EMP can, so I at least had one battery. What we're going to do, the way that BioNO says to handle these is to charge them to 100%, which is going to be something like 14.4 volts, somewhere in that ballpark, and then discharge them to 50% before you try to store them for long-term storage. And it almost looks like I kind of dented that one. Anyway, so we're going to check voltages on these using the multimeter and see what voltage they're at. Not sure how well I can do this with one hand, but I'm going to try. Also, one thing I realized, I had this in here with the battery. This is all of the settings that I've written out for my Yaesu 891 in order to be able to do WinLink, because when you're doing WinLink with an 891 or you're doing WinLink with Linux, you're bound to forget how to do it. So I recommend that you write down instructions on how to do that. What I really need to do is change this up to so this is describing how to do it with the Lab 599 TX500. I have the DigiRig Mini, the DigiMini in there to handle that with the TX500, and that's the actual radio that would survive if it's here in the EMP can. So anyway, now that that's out of the way, let's hook up this multimeter and see what readings we get. This may be a little difficult to see. I've got the multimeter set at the 20 volt setting. I'm probably not going to be able to do this with one hand. Anyway, Positive goes in the red, negative goes in the black. I'll check it and we'll see what the reading is here. Okay, we've got a reading of right at 13.32. That's about 70 to 80% charged. So we're going to need to top this one off and then deplete it. Let's see what the 3 amp hour battery's at. Okay, and the 3 amp hour is right at 13.31, about the same. So we're going to need to do the same thing with it. What I'm going to do now, I don't have the AC adapters, the chargers for these in here because this is an EMP can. So I would assume that I'm not going to have electricity in the event of something that would require me to dig into this thing. So, but I do have the adapters for them. So I'm just going to charge these using the adapters, and we'll pick up from there. Probably the hardest part of this for me is going to be figuring out how to drain them and check the voltage. What I'll probably do is set up just inline the power meter for each one and just periodically check to see what the voltage is at. I want to run these down to about 13.1 volts each. Okay, the batteries have been charging for a while, and as you can see, the 3 amp hour is up at 14.3 volts, which is essentially 100% for a lithium iron phosphate battery. The other battery is still charging, but what I can do, because now I need to discharge this down to 50%, what we'll do is we'll hook things up to the 7300. I know that the 7300 on standby has a 0.9 amps draw. So since this is a 3 amp hour battery, we should be able to discharge it down to 50% for long-term storage just by running the 7300 for something like an hour to an hour and a half. So what I'm going to do is just hook it up. I'm not going to try to transmit on the 7300 because I forget the specific output limits on this. Does it say? Yeah, 6 amps max peak discharge current, 3 amps max continuous discharge current. So the 7300 will take like a 20 amp draw if I'm transmitting normally with it. So that would differ depending on your power levels. So I don't want to damage this battery by trying to draw that much from it, but just for listening, it'll be fine. So I'm just going to turn this on, leave it running in the background. I'll have my meter here to tell me how much voltage we have, because that's how you measure the charge on a battery like this. We'll discharge this down to about 13.1 volts, and that'll be close to our 50% mark. All right, so the 7300's running. That's mostly it. So thanks for watching.